Hey everybody, and welcome to some stoichiometry, which is probably have you terrified, but it's really not that bad. So we're going to get to the heart and soul of stoichiometry today by discussing these mole-mole ratios. So when you're given a mole of one compound and you're looking for some other compound, the mole of the other compound. So those are what those questions are going to look like. You're going to be given moles of one thing and you want moles of another thing. So our learning goals here, we're going to go back to the basics and interpret balanced equations. We're going to write mole-mole ratios from those balanced equations, and we're going to solve those mole-mole stoichiometries using this powerful tool, our balanced chemical equation, one example of which is written right here. So just going back to the basics here, we can read our balanced chemical equations as a chemical sentence, and that's what really gives us this interpretation, and our interpretation really is our mole-mole ratio. So I have the moles here written as the coefficients, and those are colored in that kind of like salmony color, and those are the moles. So that's where the moles are hidden, and we use these moles for the mole-mole ratio. So each one of these is moles. And remember, if there's no number written there, it's going to be 1. So I don't have that example here on the screen right now, but I can do another example of that in a different video. So when we're reading this chemical sentence, what we are saying is 2 moles of aluminum combined with 6 moles of HCl to yield or to make, that's what the arrow means, 2 moles of aluminum chloride and 3 moles of hydrogen gas, H2. And really, that's what we use for the mole-mole ratio. We're going to use those coefficients because those coefficient means moles. And in your problem, you're only ever going to compare 2 different compounds at one time. So typically, you're going to have a set moles of one thing, and then anything else that's needed is going to be in excess. So that means that we don't have to consider it. We only consider the lowest number, and that's typically what you're given. Okay, so let's go ahead and do a practice problem on this so you can understand what I'm talking about here. So now we've got our lovely balanced chemical equation, and you could pause the video and double check that it's balanced. It absolutely is. And our question is, how many moles of H2 can be produced by starting with 2 moles of aluminum? So looking at this, we're going to start by writing down our givens. We know that we have 2 moles of aluminum that are given, and what we want is how many moles of H2. So we know this is a mole-mole problem because we're given moles of one thing and we want moles of another. So the tool that we're going to use is going to be our balanced chemical equation, because that's going to give us our mole-mole ratio, and we have to have that in order to solve this problem. So our mole-mole ratio is going to be the coefficients of these 2 compounds in our balanced chemical equation. So looking up here, where there's 4 things going on in this balanced chemical equation, which 2 do we look at? We look at the 2 from the problem. So we're going to be looking at aluminum. So we know that we have 2 moles of aluminum in the balanced chemical equation, and we end up with 3 moles of H2. So this is a really, really, really easy problem as written. This is basically just kind of the concept check of, do you understand how to read a balanced chemical equation? So this one, it's not tricky at all. It's actually very easy. If we are given 2 moles of aluminum, just by looking at the balanced chemical equation, we know that that's going to give us 3 moles of HCl. Let me write that. Oh, sorry, H2. And always make sure that you're writing out your formulas. I forgot one earlier. That's bad of me. But yeah, it's just that easy. So we know just from this balanced chemical equation, our answer here, there's no math needed because you can just look at this and answer it. So the answer would be 3 moles of H2, and that's it. Right, and that's all well and good. Maybe you'll get a question like this, but maybe it will be something different. So what about if we had 2 moles of HCl? If that was our given instead of 2 moles of Al. So we're looking up here. Just delete our, well, we still want H2, but instead of aluminum, we have HCl, and we're looking for H2. So in this one, we see that we aren't given 6 moles. We're given a different number. So let's see what that would look like. Okay, so we're going to just write out our mole ratio again. And this time we're going to do 6 moles of HCl from the balanced chemical equation equals 3 moles of H2. So let's write out our givens. We're given 2 moles of HCl, and that's why we're looking at HCl now in the problem. And then we're going to use our mole ratio. And our mole ratio is exactly the coefficients on the periodic table. And I know that you guys are super smart and you guys can see that you can like reduce this by 3. I never do, just because when I'm tired, I'm taking exams. I don't want to mess up anything. So we have 6, according to our balanced chemical equation, 6 moles of HCl will give us 3 moles of H2. And we want how many moles of H2. So maybe you'd be able to do this in your head. And if so, you notice that like, oh, we're starting with 6 moles. We have to divide that by 1/3. This is like, if you're taking a recipe and dividing it by 1/3, you divide everything by 1/3. The same thing can happen here. So we should end up with 1 mole. But let's just work out the whole thing, just in case math is maybe not your favorite. So the way that we're going to set this up every single time is we're going to put our given right here, our given number of moles, and then we're going to have our mole ratio here. So the moles of the given from the balanced chemical equation go here, and the moles of what you want from the balanced chemical equation go here. And this is always going to give us the format of our answer. And our answer for this is always going to be in moles. Okay, so now let's take a moment, and you can pause your video and try to plug it in and chug that and see how you get. So I'm just going to go ahead and delete this and plug this in for myself. So we're going to start. We were given in this problem 2 moles of HCl. Then we're going to plug in our mole ratio. Our mole ratio is 6 moles of HCl equals 3 moles of H2. So we know when it's written as an equal sign, we can write it as a fraction. So 6 moles, HCl on the bottom, the moles of the given go on the bottom, the moles of what we want go on top, and we want moles of H2. So that's why that's on top. So it's really super important to include the formulas, because moles of HCl will cancel with moles of HCl, but it will not cancel with moles of H2. It has to have the units and the formula have to be identical for it to cancel. And so now all we have to do is just this little bit of math. 2, remember cross means times, 3 is 6, divided by 6 is going to give us 1. That's too far away from me, so I'm going to delete this moles and move it over. 1 mole, and what is our final unit? Actually, moles of H2. So let's double check and make sure that's what we wanted. It is what we wanted. That's what the question asked for. So we are done. Wait, sorry, what we wanted was up here. How many moles of H2 can be produced by starting with 2 moles of HCl? We can produce 1 mole. So I hope that this helps you kind of see that from our balanced chemical equation, we can double things, we can take 1/3 of a thing, we can take half of it, but what you're going to do is all those coefficients, you'll double all of them, you'll take 1/3 of all of them, or you'll keep them the same. It's just a ratio. So these balanced chemical equations, they're just ratios, and as soon as you can interpret it, you can write those mole ratios, you can solve any problem just by using this method. Good luck and happy studying.